All right, so we left off here where I've got the snow falling, and at the bottom we have this slider bar we made last time where I can drag it over to control the wind. Max on the left, still not that fast. We could have made it faster. In the middle is mostly straight down, and max to the right is, a nice strong wind, but nothing too crazy. Now today what I want to start adding is some accumulation where the snow builds up on the ground and starts piling on each other. This could be really complicated because if you imagine we've got a couple hundred snowflakes and then they land and we continue to keep track of them and we have a couple hundred more, that would be thousands of things combining with thousands of other things, and we have to check if each one hits it, each one. That might take our frame rate down to 2. So I want to try to simplify it a little bit, but you never know. It might just have to go one by one. I remember seeing a video from Jonathan Blow, who programmed a game called Braid, and in Braid you can reverse time. You can go back in order to solve puzzles and things. And he was saying, we tried to make it efficient. I kept thinking of ways to cheat and get around it, but then I realized, no, we'll just actually remember everything so that you can go back in time. So for us, I want to try some very simple ones today and then build up to something a little less simple, but I'm still not going to keep track of every flake. So what's the absolute simplest? Well, what if it just fills up on a straight line like we're filling the room with water? In that case, we just keep the height and we change it a little bit. That could be one line of code, maybe 2. Let's see how it goes. Imagine we just have a big rectangle and it starts under the screen, but then it rises to cover the screen. Let's say pygame.draw.rect. We go screen and then the color. We might make the accumulation a slightly different color to distinguish it from the flakes, like maybe it's a tiny bit darker or something, but we'll see how it goes when we try. And then you have a pygame.rect, I think that's how you do it. For a rectangle, we give it the 2 x and y of the corner, and then how much it goes over and how much it goes down. So I'm going to go, we start at 0, x, and then y is what? Well, it's going to be the bottom minus a certain amount. So height minus, let's just say counter. Right now counter is our frame count. So this is going to be way too fast. It's going to fill up way too fast, but just as a trial run, we'll see what happens. And then how far does it go over? Well, it'll be the whole screen. And how far does it go down? Well, I'm going to say the whole screen again, even though it starts out under the screen and then rises to slot into the whole thing. Is that enough? Let's give it a shot. I'm going to see right away. Sometimes it runs in a different spot and I just redo it. Okay, so that's way too fast. But that's something. Like, you could do that at a slower level, and it would be not the worst thing I've ever seen. What if we just divide by 10 to slow it down? And so now it's starting out with the slider bar covering it, but then it pretty soon gets above that. And this is actually not terrible. Like, if you had this in the background of something and you had the snow filling up, it would look all right. Of course, it would look silly when it got to half the screen. But in the beginning, when it's just a rising flat rectangle, that's not terrible. And it kind of is accurate, since the snow is randomly distributed evenly, then maybe it would evenly smooth out. However, it doesn't really look like what I'm imagining. I'm imagining sort of hills and snow banks and snow drifts. Maybe we can have the wind sort of scrape it up, like forming sand dunes or something. But Another very simple attempt that we could throw in here is, how about a circle? What if it's just a circle rising instead of a rectangle? It's going to kind of look like a planet, but let's just pretend it's some snow. So what if we turn that off, we comment that out, and instead we say pygame.draw.circle, and then we go screen white. In a circle we need a little bit less info, you just need the center and the radius. So the center will be off screen. It'll be, you know, let's just say x is 200 and y is 1,000 minus counter. Okay, so it'll start below and then rise up. And then for the radius, let's just say 500. It might look weird, but that's okay. We're just testing this out. I want to see if it's rising as if it were a snow pile. Again, it's going to start off screen, nothing right away. But soon, yeah, okay. It does look like a planet, but it also kind of sort of looks like a hill. Let's slow it down just like we did with the rectangle. And we could turn the slider bar off in order to see the very moment. That looks good, IMO. That looks pretty good. It still looks too much like a planet or maybe a moon with the whiteness. But the way it's rising kind of sort of does look like a hill. What we'd need is to, you know, curve back down the other way, like instead of sharply cutting the bottom and need to go whoop. We can learn about different parabolas or different Bezier curves of some kind. However, those are not built into Pygame. We'd have to code the math ourselves. But what if we just had multiple circles? This is going to be the most complicated I get today. Maybe we'll get into something more complicated in the future. But what if we just had several circles throughout the screen and they all added up to sort of a lumpy snow accumulation? So what I'm going to do is every slice of the screen, maybe 20 pixels or so, will have a circle that grows every time a snowflake lands in that slice of the screen. They're random, so it'll be mostly even, but not completely. There'll be one area that gets a little more, one area that gets a little less. So what I'm going to do for that is, let's do a dictionary. It could just be a list, but let's do a dictionary. Let's call it accumulation. Only problem with that is that it's annoying to type. But let's say we're going to go x and then 0 for x in range 0 to the end in chunks of 20. So this is like if you sliced the screen into rectangles, and there's one that's the first 20 and then the 21 to 40 and so on. If a snowflake lands in that zone, we'll say, hey, that slice has more accumulation. If you did rectangles, then it would just be a bar graph. It would just be like, oh, how much has been in this part of the screen? But instead, we're going to do circles, which will kind of lumpily overlap into each other. So let's say whenever a snowflake lands in that zone, we'll add 1. You know, it'll be like, okay, this one has 1, this one has 3, this one has 7. Later, we could do something to count. I was going to say count the bigger snowflakes as more, but in theory, they're not bigger, they're just closer. I don't know. So let's just say if snowflake dot y is greater than height, I'm going to say height minus 20 to like catch it before it hits the ground, because they internally reset themselves when they hit the bottom. I don't want to mess with that. And I know this is a little inefficient checking it twice, because the snowflake knows to reset itself to the top when it hits the bottom, and now this also checks if it's at the bottom, so that's doing it twice. A little redundant, but should be all right. And now let's say accumulation of what? So we have to figure out how to translate their x-coordinate into one of these slots. Because we're not literally tracking every pixel, right? Like we're not saying, oh, one snowflake has landed on this slot and 0 on the next pixel, because that would be so much, and they would be spread out so much that it would basically be flat like our original one, except using a lot more trouble to get there. So they're in slices of 20, so we're going to go snowflake.x divided by 20 times 20, which looks very dumb, but what we're doing is rounding it, because when we divide by 20 with the double slash, you get a rounding to an integer, and then when you times 20, you get back up to not quite where you started, since now we're in chunks of 20. Or at least I think. I haven't run it yet. Maybe I have no idea what I'm talking about. That gets a plus equal 1. Okay, so that gets 1 has landed in that zone. If you divided the screen into columns, then the 1 is landed in that column, and then another is landed in some other column. Okay, and in fact, let's just print to see if I'm crazy. Let's just print for something in accumulation. I guess we're going to say column, or just x, and then how many. I'm going to call it r because it's going to be the radius of our circle. For xr in accumulation dot items. No, I already hate the names. We'll change it. We're going to print x and r. Or we'll say if r, print x and r, because I don't really need to print all the zeros every time. This is just a test to see if we're actually doing anything. If we get nothing printed, that means they're not growing in the data. But once we see that they are, then we'll use that to draw some blobs. Now, every time I run, it's putting the screen in the wrong location. We got to figure out what's causing that. But by the way, I did see something print, which means it is keeping track somehow. Okay, so yes, some of them are big, some of them are small, and it is keeping track of how many snowflakes have landed in each zone. Okay, so now instead of the print, or we'll keep it for a minute, we'll draw a circle to say like, oh, this area is getting a bigger, hill in its accumulation of snow that has landed in that area. So screen and white, and what's the center? It's x 0. Am I doing that right? I don't know. And the radius is r. Okay, so let's try that. They'll be tiny at first, and they'll be behind the slider bar, so we won't see it, but then they'll emerge if I set it up. Or maybe they're not. Let's, oh, they're coming out of the top. That's the opposite of what I meant. I should have put height here. Okay. But that does kind of sort of look like what I had in mind. Like a cloud is sort of lumpy and uneven, but still round. Yeah, we should turn off the... oh, that looks wonderful. That looks wonderful. I mean, it does look like fungus growing in a petri dish or something, but it's random, it's continuous, it's mostly not sharp, although every once in a while there's like a widow's peak right there, but they're mostly kind of cloudy looking. And I'm going to turn off the slider bar draw so we can see the base tiny versions at the bottom. The spores of our mold. At first it's going to look like the snowflakes just stick, because that's kind of what we're trying to simulate, right? And then you see the circles grow based on if flakes are landing in that zone. I think that looks delightful. And it's only 5 lines of code. And it's not that bad in terms of performance. It's not like we're keeping track of hundreds of combinations of hundreds of things. It's just, what, 20-something numbers. So that's not bad. It, of course, just like all the other ones, looks ridiculous when it fills up half the screen. So maybe we can just have them max out at a certain value. But I think it looks delightful when it gets going. You get some snow sticking on the bottom just like it would in real life. And then they start to combine into each other as they get bigger. And then it all starts to grow in a way that kind of sort of looks like snow would, with maybe a little wind affecting it. We don't have the wind affecting it. Like once it's on the ground, it's not being blown by the wind anymore. But maybe we could have it sort of push the big boys over a little bit if we think that might make it look nicer. So that's pretty cool, and that's where I'm going to stop today. In the future, we might do more advanced versions of accumulating snow where we actually keep track of each particle and we actually make new ones when they hit the bottom. But right now, we're still doing our original recycle method where when the snowflakes hit the bottom, they just teleport up to the top. We keep the same amount of snowflakes. We're not adding more and more and more. We're just doing a couple more circles to remember the places where the snowflakes have been. And that is all right. I'm not going to call it beautiful. I'm not going to call it done, but I'm going to call it a nice prototype. Thanks.